I see you in a picture frame.
I know I was supposed to have everybody else in the picture frame. Oh, wait. Okay, it worked. Hello, everyone. Thank you for tolerating our Halloween obsession here. Halloween is a super important holiday to many of us, and it's not just Halloween, but all the fall traditions. The autumn of the year is an important time, so we try to make it fun. Anyway, thank you so much for being here. Today, I think we'll go around real quick and do a stand-up of what we've done over the past week, what we're doing over the next week, and if we need any resources or have any roadblocks. So let's take care of that first. And I think everything that I have to say is going to be in the going through the Teckle script and figuring out how to get the encoder working. So we've been working kind of hard on this and lots of different stuff with that. And the learning rate has been very high, which is always good. And I think we're close and all that. So that's basically what I have to say. And I'll hand it over to Paul, and you can hand it over to the next person.
Okay, I have nothing to report to speak of. The remote lab is still there
because of hard work. Thank you.
I will pass it over to James.
Not too much to report from Remote Lab South. We're doing well down here, and just getting more work done. We've had some more extreme weather lately, but nothing that's been slowing us down. So we're just continuing moving equipment in.
Yeah, I saw the front that went through Texas. Wow. Did it whack you?
I believe it's not quite. We've not been whacked. We are currently in the process of seeing it. Like if I were to poke my head outside, it'd be taken off by the wind.
Oh dear. Okay. Yeah. Well, stay safe. And how close are you ready for the shipment of stuff?
For that, I have to check with Keith to see how close we are there.
Okay.
But,
yeah, I'm keen to get that equipment to you because I know that at the very least there's a computer in there that Anshul was interested in getting, and there's some equipment that we would really like for power bus for Hyper-IEA. So as soon as you can, no pressure, let me know when we can transport the lab equipment from California to Arkansas.
We will let you know.
Okay, thank you. Okay, Anshul, welcome back.
Thank you.
We missed you.
Yeah, saw your message. Yeah. Now back, going through all the Slack messages, seeing the progress. Thanks, Michelle. It's amazing. Now we are so much close. So yeah, I am thinking whether I should try what you are doing or shall I continue with MQTT. So yeah, I will go through the messages and see how things work out, because I'm very close to get the MQTT also working. So yeah, let's see. But overall, I think that we are very near to see things in here.
Yeah, great. Yeah, definitely. MQTT is really cool. It's not something that I'm very good at programming or using, but the understand the concept, and I think that it's a very powerful thing for radios, and that it will make it super easy and wonderful for us to use. So yeah, please proceed. I don't want none of this discussion should be against that. It's not either or, so because I think MQTT probably uses the same sorts of calls, the same sorts of Linux calls, and the same libraries that we're trying to get working. And, it's been a little, I'm just kind of, I guess I'm like, wow, this has been kind of hard to get it up and running. And now I think we might be more onto it. So yeah. So what we should probably look at is the way that our development system is set up is that you go and get the repository that Anshul owns. This is the ADI ADRV 9371 ZC706 repository. And what that does is a lot of clever things. So when you clone this repository and then run make, what it does is it pulls in a lot of other repositories. And so what we've done is we said, okay, this HDL reference design from ADI for our hardware, for the development system, we've snapshotted 2021.1 version of that, and that's pulled in. And we've also pulled in all of Andre Swato's work for the encoder, and we've snapshotted that. And so those two things are submodules, which for those of you that don't know about GitHub and repositories, submodules are pretty powerful, but they can also be a little confusing, and they can add some complexity to your design. And so this repository is pretty cool because it's two submodules, one from Analog Devices and one from a contributor. And then so Anshul is like, okay, we'll need to integrate all of this work for a device we have in the lab. So what we have in the lab, what Anshul has where he's located, and what we have at Remote Lab West, and I don't think this exact hardware exists at Remote Lab South, James. So you have you have an UltraScale Plus board and not this particular one. But the things that we're dealing with here are the things that you're going to have to deal with there when you get it up and running. So it's still relevant. So what we have is a ZC706 board from Xilinx, so 7000 series FPGA, and a really cool software system on chip from Analog Devices, the 9371. And the name of the board is the ADRV 9371. So when we keep saying that, that's what we're talking about. And these two boards fit together with this a huge connector, so you get it together and then you put it on the air. And so together it's an FPGA and a RFIC system on a chip and all sorts of other circuits. There's just a crazy amount of components here that we're talking about. And once you kind of glom it together, you can target this and make a radio. So that's our development situation here. And what we've done is made it even harder by saying you can access it remotely and allow people to participate that otherwise normally would never be able to use these sorts of systems. Now, where we have to pay the piper is that the 9371 and the ZC706, the 7000 series from Xilinx, they're all pretty complicated. And so I think some of our assumptions have been maybe a little incomplete, not wrong, but incomplete. And I think that what I did recently trying to fix the bus widths was wrong. And so what I'd like to do is try to figure out how to fix it. So what I can do is share the screen. This would be, of course, easier in person, but I'm going to go ahead and share the screen for the TCL script. So TCL stands for something. I knew this yesterday, but TCL is a sort of a language. So it's a scripting language that is used all over. And the TCL script in question is what we are using in order to when you run the make file. So you navigate through to, in this repository Anshul is responsible for, you navigate down to ADRV 9371 X and then ZC706, and then you type make, and there's a make file there, and it builds all sorts of stuff, including a Xilinx Vivado project. Now in this project, then you can see that really amazing a system block diagram that we've shown from time to time. So you have a system block diagram, and you have a Vivado project, and you can then you can do synthesis, implementation, you can produce a bit file, and the bit file is what's really important for programming Pedal Linux to get the general purpose processor on our dev station up and running, and to make sure the FPGA has some sanity. So this is lots of moving parts. We have all of this documented. Oh, thank you. It's originally tool command language, but now it's just TCL, TCL. Okay, so tool command language is pretty clear. So this is a scripting language to order your tools around. And so the particular file in question has already been modified by wonderful people like Everest, who added the 9361 on the Pluto, all the code required to get this to work on the Pluto. And then we've modified it several times to to automatically integrate our encoder into this reference design so that we could start working with an actual hardware and get things working over the air, which is what we value the most. Like, we need it to work over the air to show that we know what we're doing and to move on to the next step. So what the big difference between the Pluto, where our code and our encoder works, the 9361 on the Pluto and the 9371 on the ZC706, blob that we have, the big step up there is a departure in the way that the data is sent to the actual transmitter. And the interface in question is, it went from a much more clunky, old-fashioned way of doing it to something called JESD 204B. And that, I think, might be the problem that that we've identified over the past couple of weeks, especially, and that probably cropped up earlier. So when we talk about DAC FIFOs and encoders and DMA access, I was assuming that that's where the control is. Like, we control our entire transceiver from that perspective. Okay, so this turns out to not be really the case, and that the JESD 204B interface is really that actually is super important. So actually knowing how the lanes and all of this works is probably something that we should at least double check, and that's my goal for today, is to look at our Teckle script and figure out exactly how it's setting things up. So when I looked at it and I'm like, okay, well, it's an expression that sets up the bus widths for the encoder. So what we're doing with the encoder is getting in between direct memory access. So we're pulling memory from the processor side, and yeah, that's what we should be doing. So we're getting things from the uplink, all sorts of data, all sorts of traffic, who knows what, and we're figuring out what to do there, which is super fun and a big challenge. And we're getting, like, here is the baseband frames for the downlink. So baseband frames, when we talk about baseband frames, we're talking about DVB S2 and S2X frames. And we have a variety of ways to do this. Yes, you can do it directly from GNU Radio. You can create baseband frames from there. And we know that we can, because we meaning Paul, wrote a Python script or a Python notebook that creates BB frames from MPEG, transport stream. And it turns out they perform exactly the same, pass all the tests. So we have at least two ways to create these files that are directly sent to the encoder. So our encoder, our downlink encoder. And this is a big step forward. So now we have some ownership over this. We don't have to depend on GNU Radio. It's not that we hate GNU Radio or think that it's bad. It's just that here you go. You have a Python notebook way of doing it. You can also do it in GNU Radio. If there's a third way to do it that somebody listening to this wants to contribute, party on, really. Multiple ways of producing this data stream are super important. Once we get these BB frames, the thing that we need in our system is that all you need to do is have one 32-bit word that tells us what the frame type and the the modulation and the code rate are. Okay, so that's a configuration word that really kind of like sets the stage. So this particular frame, this baseband frame, needs to be transmitted with these particular aspects in DVB-S2 and also S2X, although we haven't added all of that. And that's where we kind of tripped over our own feet. And it just doesn't work on this larger FPGA system, the ZC706, but it does work on the Pluto. So the big difference is JESD 204B interface is used on the ZC706. It's not used on the Pluto. It uses an older method. And also we have a signal that does not exist on the Pluto working code. So the working implementation on the Pluto doesn't use the DMA transfer request line. And this is a signal that goes high when you have the start of a transfer, AXI transfer. And this particular signal is actually consumed and is part of the logic of the DAC FIFO for the 9371 design. And so I think that that's something that we need to take care of. And I'm not sure exactly how to do that yet, but it may just simply be that we need to pass on like the valid signal. In AXI, the valid signal means, hey, I'm a transmitting block of code or block of logic, and everything that's now on the bus is valid. That's actual valid data. Before that, if I say that it's not valid, I'm not ready yet. Because in AXI, all the handshaking and the control for all these buses between all of these different blocks, AXI can tell you, yeah, my address might be valid and everything else is valid, but wait on the data, not yet done processing it. This is a very powerful thing, but powerful things are also, they also have a cost of, you have to actually take care of all the complexity. Okay, so I hope that I've done a good job of framing the past maybe several months worth of work. And I'm going to stop here and let other people talk about what we've looked at and accomplished, because I haven't even touched on the registers. We have a script that returns registers, and I'm not the main one that's worked with those results. I think it's Paul. And then Anshul has a tremendous amount of work under the belt here. So so I'm going to stop and turn the floor over to everyone else to make comments on this. And then after everybody has said everything they need to say, then I'd like to go ahead and move to the Teckle script and look at the expression for the bus widths, because that may be tripping us up. That's what Swato and also Everest have recommended that we look at. So I'm going to mute.
Michelle, is it the same signal in our earlier FPGA meetings? You have been, from beginning, you have been concerned about this signal that we haven't connected this one. Is it the same one? You mentioned about this earlier also, and you were concerned when we were facing the issue where we were not using the correct address at that time. Also, we did debug this, so it's the same one.
Yeah, it's the same one. I think it actually, it turned out it was in the image from last week's meeting about DMA. Well, on one side it's called I think it's called DMA X for XFER request, and then MAXI transfer something on the DAC FIFO. So originally in the reference design, the DMA and the DAC FIFO are connected directly. Like there's nothing in between. So once we get in between them, any extra signals, it's not, so it's not just all the standard AXI signals. There's this one extra signal, and it goes high at the beginning of a DMA transfer. And so since we're not giving it to the DAC FIFO, I was like, oh, so it's never, and it's used to reset the DAC FIFO. So it's just sitting there waiting for a reset signal, and maybe that's why we're getting all these timeouts. So that was my first thought. I don't know if that's completely correct, because I'm not yet. I'm trying really hard, learning as much as I can. And so I think I could probably prove this if I could put like an ILA in there, you know, a logic analyzer block in there, or if I knew how to get the results back out. But just looking at the signal and looking at the Verilog code for the, you know, from ADI, from analog devices for the DAC FIFO, it looks like it's expecting the signal. And since we've put so much pipeline delay with the encoder, and another neat thing about this is that our encoder has a variable pipeline delay. So like things that with a code rate that's low versus things with the code rate that's high, you can see where it may take a while for the encoder to like, okay, wait, I'm working on it. You know, I've got like a 1/4 rate, like, okay, one bit of data in, I gotta come up with 3 other, you know, priority bits basically. Yeah. So you can see where the delay is variable versus a low code rate that's nearly 1, you know, you might beat it, right? And we see this, I think, with some of the experiments we've done. The encoder will work fine. It actually, the transmit and receive, it clocks along, and it doesn't have that weird timeout from the buffer. So I guess that's why I think that that we have an issue with this particular signal, because it's still hooked up and it's still in the TECL. So now we're back to the TECL script. This TECL script actually runs the show. My misunderstanding was that the block diagram that you get, that awesome block diagram, and you drag and you drop and you hook things up and everything. Oh dear. So none of that matters. You can change things in the block diagram, but the TECL script, if you hit make or make clean, or it will overwrite everything unless you change it in the TECL script. And I didn't really appreciate that until I guess a couple of months ago. And now I've been reminded that, yeah, you need to actually programmatically, like you need to specifically say in the TECL script how things are hooked up. And that signal is still hooked up in the TECL script. And so we have to, if we have a timing problem because we've inserted a huge pipeline delay with the encoder. It's consumed. And then the Pluto works fine. The signal's not hooked up in Pluto at all. It's disconnected. So I was like, well, we should disconnect it too. But the Pluto design doesn't have a DAC FIFO. But we do. We have a DAC FIFO, and it needs the signal in order to reset it properly. So we either go change the code from analog devices, which sounds dangerous and risky, or we give it what it wants. And that may mean just tying it high, like we're always transmitting, because we are always transmitting because we're DVB-S too. So, there's kind of janky ways to fix it. Like we can just tie it high or whatever it takes. But I think we should probably look at like actually giving it what it wants, like delivering a signal. Like I have a transfer. Like, okay, it's not a direct from DMA transfer anymore. The signal, this particular signal goes high when there's a, yes, I'm DMA, but this needs to come from the output of the encoder somehow. And it's like the encoder is now ready to deliver what essentially used to be transfer from memory. And now it's a transfer from memory that's been modified. Now we're giving it to you. Is that, I'm not sure if that's clear. Does that make any sense, what I've said?
Yes, of course. Yes.
Okay, good. Yeah, so I'm not sure what to do about it, because we could, and I really don't want to change the encoder, especially because it works. Like it works in a general case, like you get data from memory and it produces I's and Q's. And at that point, we should not want to add anything extra for a particular implementation. So it's kind of on us to add something else outside of the encoder, like inside the wrapper, like, because the inline, the thing that interprets the control word that tells it the frame rate, the frame length and the mod code, that's outside the encoder, but it's inside the wrapper. So maybe we need something else in that category. Or I asked our Qualcomm person, like, can I just use valid? Can I use AXI valid? And I haven't heard back yet, but something simple would be best. So that's good. And I should mention that let's see, Paul mentioned the Jupyter Notebook referred to he puts a link in chat for the conversion notebook for going from MPEG transport stream to BB frames. And he's now tagged it. So tagged with mode words. Okay, so they put the direct link into chat. And Sasha says hello and has audio challenges today. Hello, Sasha, I see you. And then I also see Rick Hambley. Hi. So I just wanted to acknowledge everybody, welcome them to the meeting today. So, all right. So I'm gonna stop talking and let anyone else weigh in here. And then what I'd like to do is look at the TECL script and figure out what the JESD 204B interface to the transmitter is really expecting. So I'd like to actually look at the code, put it up on the screen after we're finished going around here. and see what we're supposed to deliver. You know, how wide and how many samples per per clock cycle, because I think that's something that JESD 204B is demanding, and I don't think that we're giving it that. So I will be quiet now.
Yeah. One request, since I'm not up to speed about what issues are we facing and what is the problem, can we take this up next week? Are you better prepared? I mean, that's up to you, but yeah, that's what I think.
I'm sorry, I missed the very last part. You wanted to take the next week and then I didn't understand it. I'm sorry.
Yeah, I want to take this problem up next week so that I'm prepared of
okay, yeah,
what
sure.
exactly the issue is, and so that I can come up with some solution or something.
Oh, okay, yeah.
Understanding, yeah.
Yeah, the issue is that we're getting timeouts.
Yeah.
On when we're trying to use the encoder on this particular on our development station. Okay, so yeah, of course we can. I think this will take at least another week to fix. So we're not gonna fix it today. What I wanted to show was what I wanted to do was get a number of eyeballs on the Tuckle script today to where we can figure out what the expression is really telling us. So no pressure on you whatsoever. Yes, we will continue to talk about this and let you catch up over the next week. So no, I'm not expecting. If we solve it today, that'd be great. If somebody sees something obvious. So then I think the next thing I would like to do is just show where this expression comes from. So this is setting the bus widths. I thought was just, yeah, you just set the bus widths, right? Because, you know, the DMA controller, the direct memory access controller, okay, I'll probably get this wrong, it was pulling 64 bits out at a time and giving 128 to the next block, which was the DAC FIFO, right? I think that's right. Okay, so 64, because we have 64-bit wide memory. Okay, sure. So you're taking out 64 bits at a time, and then you're giving 128 bits at a time to the DAC FIFO. The DAC FIFO consumes the 128 bits and then gives 128 bits downstream, all the way down, all through all of these amazing little blocks to the JESD 204B interface. So, and I think now that the way that you'd set up that interface, JESD 204B, is where like you really have to give it what it wants. Like you don't get, like there's no FIFOs and adjustments and stuff, which I'm used to from previous work where you had a little more flexibility. I think we're running into a problem where we're not going to get the results we want on the spectrum analyzer until we nail this. So yes, the answer to your question, can we put this off a week, is yes. But let's look at the code and see if we can understand the Tuckle script a little bit better. Because I just thought I thought this was much more flexible than it is. And just walking in there and commenting out this expression and putting in the number 32 and going, woohoo, I did it, was not it's okay. Well, it worked. Like a lot of those critical warnings went away, and all of a sudden, I'm like, oh, look, I get RX and TX at the processor side, and I'm like, wow, why is it still not working? Okay, so, you know, it's my bad, right? So I don't know. At least let's take a look at the script and see what we can find, and if we can get like if someone like me, you know, I'm a little slow. Like if I can understand like what have we set up for? How many samples per whatever's per, you know, there's 2 dimensions on JESD interface. It's really pretty cool. So if we can at least get that under our fingers, so to speak, then I think that our tests in remote labs can actually make more sense. Like we know what we're trying to feed it. We thought we knew what we were trying to feed it, but we don't. Okay, so I will look at my desktop and I'm going to make it to where anybody can share if they want to. So let me go figure out what I want to show. And I want to show the actual Tuckle script from our repo. It's in one of these tabs. There we go. Okay. Oh, I got a lot of choices here. Let's see. All right, I think that worked.
I don't see anything yet.
Oh, that's weird. Okay. I'll keep trying. Let's see. Did I? Yeah, I did multiples. Thank you for patience. Oh, I have to actually click share. All right. Okay. I've been informed that you can actually see a Teckle script.
It's pretty tiny, but we can see it.
Oh dear. Okay. I don't want tiny. Let's see. I'm going to try to click on raw. Is that any better?
No, but if you can make the font bigger, it would be.
Let's see. Is this any better?
Yes.
Is it? Oh,
Keep doing
good.
it.
Okay, I'm going to keep doing this until. All right. How's that?
That's very visible.
Oh, good. Okay.
Yeah, that's fine.
Oh, good. Thank you. All right. There we go. I think that that might be 80 columns. And I can also see all of you still, which usually doesn't happen in Zoom. Okay, so the JESD stuff actually is at the top of the file. This Teckle script is the ADRV 9371 board file, and this gets called in the make process. When we make our Vivado stuff, our Vivado project is where the bit file and the XSA, which is a Xilinx system archive file, comes from. And the Xilinx system archive file goes directly into making the Pedalinux build, and so does the bit file. The bit file goes to the FPGA directly. The XSA handles everything else. So these files and this particular file are kind of important to have all this stuff work. And any complicated system we have, yes, we have an FPGA, and yes, we have a awesome Zinc processor. And so this file is actually in charge of a lot of stuff. So we have things like max number of lanes, and we have max receive number of lanes, and the OS here means the observational receiver. So we have these really cool things in the 9371. They're observational receivers that can look for stuff and then inform our system of, hey, you have a signal over here that you need to pay attention to. We haven't really exploited that yet. These letters here for JESD M, L, S, those are important. I know from reading in the past. So you can see that this stuff is set up. We have parameter descriptions, and we set the number of lanes for JESD interface. And, I never really paid a lot of attention to this, but we have the samples per channel, and it's an expression. So we have the number of lanes times 32 bits, number of converters. We have another L and an M and an N. And this stuff, I think, is the key to what we're dealing with. Okay, so where did I screw it up? We know that our encoder is 32 bits wide, and we know that we were trying to insert ourselves into a 128-bit wide bus, and it looks like that you can just fix everything by just modifying the bus widths at the encoder, and that does not appear to be the case. Here is where we actually source our DVB modulator. So you can see that we have our DVB-S2 files, Teckle script, our encoder wrapper, VHD. This is what we've been documenting in the draw IO. This is where it actually happens. So we source adding the files. This Teckle script in particular figures out where stuff is in our repo that we're adding to this reference design. And here is the resulting wrapper. And then we set the instance, and we start setting properties. What I'm looking for is the bus width. This is with the data width for us. So you can see we're clearly declaring ourselves as a 32-bit wide thing. And they're 32 bits. So 16 bits is I and 16 bits is Q. Well, actually, the input data width is not I and Q. The input data width is the BB frame data, but the output is a 32-bit wide word that's I and Q. So we're just putting out one I and Q at a time. And we have all of this neat stuff. So all of this ADI connect stuff, where we go from the transmit DMA to the encoder, and from the DAC FIFO to the encoder, this is how we insert ourselves into the design. So the rest of this technical script is all of the other stuff that comes from the reference design. This here, this is how we insert ourselves into the design, and it's all working as intended. Okay, so I'm looking for, okay, I'm looking for the actual bus width that I modified. And this is the one that actually is working. Not the one that I modified is in a pull request. Still looking. Okay. I was expecting to see it somewhere around here. If I can't find it, it might be further back up because some of the stuff is scattered around. But okay, so I'm going to just say in here somewhere is our, you know, the DMA connection, and then it has been reset. And the values come from way up here. Like we set the bus width with this expression. And that expression consumes things like the transmit samples per channel. Okay, so there it is. Here it is. Okay, so when we set the DAC DMA data width here, this says DAC DMA data width. This is 128 bits, and this is actually what's coming from the DMA. This exact expression is used in several places. And what I did is I commented this out and just put it in a 32. So you can see it has the transmit sample width, it has transmit number of converters, and it has a transmit samples per channel. Okay, so all three of these things are important. These all come directly from the JESD204B interface, and that's what I claim that we need to be able to master, and we need to be able to understand exactly what we're interfacing with in order for the encoder to work with a 9371. We know that the encoder works with a 9361, I'm not going to say simpler design, but one that has a not so maneuverable and not so amazing interface. JESD204B is really amazing. We really should use it. We should not back off of this. We should keep attacking it, and we should master it and then use it and then produce this design. We should keep going. And we should also publish and use and publicize the working design on the Pluto, because the work that Evereast and Anshul and others have done, and that Andre has enabled with this encoder, is really cool for the Pluto and for any design using a 9361. The more modern interface, the JESD204B interface, it is great, but we're dealing with a more complexity. And so this particular statement right here, the one on your screen, is the one that I changed, and I think that derailed everything. So over the next week, let's go on Slack and let's figure it out. Either we need to back off and we need to say, okay, we're going to go down to 32-bit at a time encoder, or we need to take the encoder and step up to 128 bits wide, which is what the JESD204B interface is expecting. All right, that's what I got this week. All right, discussion, floor is open. All in favor?
Yeah, Michelle, you're correct, but yeah, I need some time. I understood the problem, but yeah, I need to work on it.
Oh, sure. No problem. See you soon, Anshul.
Yeah.
Oh, it's a good question. Sasha says, do we have a working example with just D204B, even if it's not with our encoder? If just something added single, yes, we do. And we got really comfortable with it. The reference design that we're using works great without our encoder in it. And we sent lots of sine waves. In fact, the ADI does a great job of shipping a working example, a hello world that is 2 sine waves. So you send a 2-tone example. And to their credit, they've actually given us, I think, everything that we need in order to figure out what we're doing. It's just maybe it's aimed for people that do this every day, and maybe not folks that are coming at it from our particular direction, which is a different one. So yes, we have those working examples and lots of videos and demos of us using it. It's our attempt to insert our encoder with an impedance mismatch, so to speak, into the mix that's been a little bit uncomfortable, but we're super close. And we have a lot of confidence in this encoder because it works with different architecture.
Yeah, the ADI reference design is just trying to show us how to use the radio. And we're trying to do something more FPGA oriented and missing some points. So
Yeah, I think the 2 points that we need to get under our fingers better are the signal from DMA to the DAC FIFO that we have to respect. Maybe purely just for timing, and really understanding what the JESD 204B interface incurs, because it's all great to have it, but unlike other designs that I've worked on, the interface way down the pipeline actually propagates back. So the requirements actually propagate all the way back to where we are. And what I assumed was flexibility in terms of FIFOs and stuff, and buffers. It's a flexibility with respect to timing, but it's not a flexibility with respect to the format of the IQs that we're delivering. And Sasha asks, can we try doing something simpler with just putting something in memory without the DVB encoder and figuring out how to do DMA? And yeah, we've done that. That's what gave us the confidence to drop the encoder in. So we thought we knew what we were doing, but they've made it so easy with the hello world and the stuff. We've done your suggestions are awesome, and they're exactly the right thing. So I just want to highlight that Sasha's recommendations and advice. Sasha's second week on the project. Thank you. And yes, we blundered right into this more complicated implementation of our design. We had lots of confidence because everything seemed to work and we thought we understood it. So we're approaching it as you have an I and you have a Q. That's your atomicity, right? That's your atomic unit. No, you can actually change that with your JESD 204B interface. You can decide that you are going to accept only, that you need an I and a Q and an I and a Q, and 2 samples wide, essentially. And it looks like that's what we might have set up now. Or, because why else? Or you look at it, it's like, why in the world are you shoving things out 128 bits at a time? What are you trying to? And they're trying to show off their the bandwidth and the capability of this particular system is quite remarkable. And I think that they're like, yeah, sure, we're gonna fully ventilate this 8-cylinder hot rod, and we're gonna show you what some good valve work will do for you, and you're like, wait, I just wanted a VW. I just wanted it 32 bits at a time. And it's a misunderstanding on our part, I think, about the JESD 204B interface is probably in the mix here. And also not understanding that when you insert logic, you really do need to make sure that there are signals that you're taking care of. And we're not taking care of a signal in particular that's consumed by the FIFO before the DAC FIFO is what they call it. So, but your advice is absolutely spot on and right. So In fact, going back to those examples and then working with those examples with their example code and the stream that we're working with, the processor side code that we're working with is actually one of their examples. It's based on one of their examples. So I think that dropping back to just the reference design at this point, and then going in and manipulating the bus widths and proving that we can send a sine wave to very simple signals and fully controlling the interface closer to the transmitter, so to speak, would be actually very valuable. At least it would be for me. So, not being as brilliant as the people that contribute to this project, it would really help me figure it out. So I think that's what we'll do. So we will take your suggestion. That's a good one. Thank you. All right. Anything else? Oh, thank you. Sasha is also working on the radio frequency side of things this week, and I'll try to put together some meetings with people that have helped us outline the architecture for the RF. And when we talk about RF, we're talking about RF on the downlink. We really need to start specifying actual components for the 10 gigahertz downlink. This is all of what we've worked up so far has been essentially baseband, even though we are transmitting up to 6 gigahertz with the equipment that we have. In order to have a legit 10 gigahertz downlink, we need to start specifying the components. And one of the big things is the switches that allow us to fail over, and all the sensing and feedback loops for that. So thank you so much, Sasha, for pitching in here. And I think that we have some other people that might be interested in helping. I'll try to reach out again to Dr. Bridges, who helped put together the architecture in the first place back in 2020, and then see if he or any of his students want to help out here on that. And anybody else that's listening, if you're interested in space 10 gigahertz downlinks on the amateur bands, then we're trying to build some prototypes and get some things rolling. All of this will roll into the open source HEO project that we're working with the Hyper-IEA. Okay, yes, I will. Sasha says put people in contact, so I'll do all that I can to make that happen.
I have an opportunity that just arose last week. I got invited to a Ham's house not far from me that I had met once, but didn't know much about him. And turns out he's a microwave expert and an RF expert, and his lab has far more advanced RF equipment than my lab, and that's saying a lot. He worked for Hewlett Packard here in Colorado Springs, among other places, and has a 140-foot tower with almost nothing on it at the moment. All his antennas are in design on short masts at the base of the tower, because he never finishes his designs and gets them up on the tower. But his designs are most intriguing. And I mentioned this project to him and said, wouldn't it be nice if there were like more than one person in Colorado Springs interested in this project, so that we could like maybe even put up a couple of transponders and talk to each other. And he thought maybe he would be very interested, which would give me the second person.
Yes, that's for microwave work. That's really kind of important, isn't it?
Yeah, I haven't asked you for anything, because what good is it with only one person?
It's good for a little while, as long as your curiosity lasts, right? But being able to complete the link is
yeah, if I put something up on his tower and something up on my barn or somewhere because I'm much higher. I know we can talk to each other because it's only 10 miles, 12 miles apart. But just saying, there may be another qualified, interested person out there.
Oh, good.
And not just RF, but I was trying to find out what his interests were, and apparently he got upset because he had bought an Orion 2800 rotor and put it up with his 40-meter beam at 140 feet. Now you might ask, what does that have to do with this project? Well, he made the mistake that I did not make when I did almost the same thing in Maryland. I bought a different brand of rotor controller, the Green Heron. I did not buy the controller from Orion because I knew that was not a good idea. But he bought the Orion controller. Sure enough, it failed. So what does he do? Designs his own FPGA-based controller for the Orion rotor. And I said, what? So he also has talent other than just microwave.
Wow.
He does at least, now he didn't lay out his own PC board. He took, I forgot which kit it was. It wasn't the Z board. It was a smaller one with the same processor.
Zybo or something like that.
One of those.
Base,
And
yeah, there's a bunch like Zybo,
Yeah.
Basis, whatever.
he put it in a box and programmed it. Programming it is the important part because that says he and I had this conversation. He thinks like a hardware person, not like a software person. Software people often have a hard time grasping the concepts of the fabric, and he did it. He just and he didn't like go do this to sell it. He just did it because he didn't want to buy another controller.
Yeah.
Now that's the kind of person we need on this project.
Yeah. I think you're right. Yeah. Tell them that, sorry, they're hired.
Yeah, well,
and-
he had asked me for a lot of information on a lot of subjects, which I then spent half a day compiling and emailed him with links to all the different things, like why should he save the 50-foot space on his tower for a 6-meter beam instead of his tri-bander? I said, no, you gotta wait. You gotta put a 6-meter beam there. And I gave him a link to Frank Donovan's presentation on 6-meter antennas. Dozens of those kind of questions. So he's a very curious guy.
Oh, good. It's really, really important to
he's
find
not
those people.
Yeah, I don't mean to sound like he's an odd guy. He's a very normal guy.
Totally.
He did not and would not say any of the stuff he said to me at the meetings. He would come to one of our Thursday morning breakfasts. In other words, he doesn't brag about what he does. He just does it. And he invented some things that in past history you might have run across, like the various buses for hard drives, including the 50 and 110 parallel buses and all that kind of stuff. So
well, you did mention he had it's from Hewlett Packard, so
yeah, he had to do something computer related. So
yeah.
he did RF studies on crosstalk and such things on high speed connections and wiring, and he's not very well known, even though he's done all this stuff.
Wow. Well, people like that are all over, and
they're
yes,
and
often it seems like they are, and I guess we just have to be open to the experience of meeting them and making them feel welcome, and meeting, just enjoying this amazing world we live in.
Well, I will let you know if this matures to anything.
Oh, good. Yeah, no, it's remarkable. I think it's great. And it just shows that you're in the right place, because where you live, there's an awful lot of really interesting people. And
Well, I was out for a drive the other day. We're exploring Colorado and trying to find places because moving out here, we want to know where it is we move to. And I'm on this back road, nothing road, between my house and my daughter's house. And we didn't want to take the main roads. We wanted to see some of the scenery. And whammo, all of a sudden, guard gates and big red lights. And I thought, wait a minute, I have a hassle to get me into any of the military bases, but this wasn't that. This was Lockheed Martin and their missile development facility. And I said, oh, well, now I know where it is.
yeah,
And there are people who worked there all their lives who
Yeah.
can't say what they did, but they're hams, and a lot
Yeah.
of them are retired.
we're out there, we meaning in the broad sense, but the amazing people are out there, and it's so good that you're meeting some of them. That's
Yeah.
that's
The
good news.
local club has one or two professors who teach at the U.S. Air Force Academy,
Oh, very good.
maybe. Then it turns out I taught at the Naval Academy, so I know it doesn't take much to become an instructor, but sometimes they're really good.
No. Wow. Well, this is really cool. I hope this continues. And you know what? If any of what we do is of interest to anybody, then they're welcome, really. And we'll keep kicking it and keep working on what we're working on and make it accessible and easy to join. That's what we do.
Yeah.
All right. Hey, any last comments from anybody before we shut down for the day? Anything that we need to pay attention to or that you want to add for the week? All right, James says he headed out for school, and good to hear from everyone. Thank you, James. And yes, Sasha will definitely put you in touch with folks. And then Paul, any last things from any remote labs?
Is Paul there? Hey, hi,
I'm
Paul.
here. Yes, hi, Rick.
Paul, I listened to your two presentations that were in the links from last week, and I was impressed.
Thank you.
One of them was on the voice codec, and I liked your punchline at the end.
I'm glad someone was amused by it. I found it funny. One of the
That
problems
whole
with these
business
online,
that whole business of vocoders, when I was actively involved in AMSAT and I was being pursued over these vocoders, trying to get AMSAT to buy in, and I wasn't very interested because there seemed to be much more interested in how good could you get a vocoder to work in a very narrow bandwidth. And I said, MSAT's not interested in 2 kilohertz channels. And now I see from what you said, that whole evolution took place anyway, which of course it had to, for this satellite project. I was absolutely super pleased at what you had to say about all that. Really well done.
well, thank you very much. One of the problems with these online presentations where you do a recording and then maybe some live Q&A is that the amount of feedback you get is very limited. So I'm happy to hear that someone enjoyed the talk and agreed with it.
That's why I wanted to say it, because I know that's exactly what happens, but your presentations, both of them were very effective. They got me fired up a little bit.
Excellent.
Thank you. We appreciate it. All right, we'll do it again next week. And until then, we'll be on Slack, figuring out all sorts of stuff and helping people to learn. So if you're watching this for the first time, or if you're watching this and want to get involved, then just go to our website. It's openresearch.institute, open research, one word, .institute, and then click getting started and join up, reach out, and start the process of learning how to grapple with all this stuff. You do not have to be an expert to join. You just have to be willing to become a little more of one along the way. And as you can see, there's all sorts of things going on. And if you have a project and you need a home and just a little bit of logistics support or a little boost, a little bit of formal structure, then that's what we're here for. All right, see you all soon. Have a very happy Halloween holiday or fall holiday. And our next meeting will be launching definitely into fall. So enjoy and see you next week.